Hello, my name is MazKhansari, and today I'm going to present a consulting project that I did for a company as part of my Insight Data Science Fellowship. The project is titled AImoji, and I was tasked to develop an AI tool to detect emotion of a sentence and suggest appropriate emoji for it to help the company with their platform and also marketing. So I had 2 weeks to deliver the project, and here I'm going to share with you what I learned about natural language processing and how I solved the project in this short period of time. Here on the left, I'm showing what Apple is currently offering. If you go into your iPhone and type "I'm happy," you will get an emoji suggestion for the word happy. But if you go and complete your sentence saying "I'm happy because you're here," there will be no emoji suggestion. This is because Apple currently doesn't have a platform to suggest emoji for the entire sentence, and this is the problem we're going to address here. Studies have shown 92% of internet users are using emojis in their text and conversation. So people are familiar with emojis, they connect with them, and also it's been shown that using emojis can improve user engagement and also improve the marketing. The deliverable of the project is a Python web app in which I'm showing a screenshot of the deliverable. The user goes in and types a sentence, clicks on analyze, and then the tool will do the analysis and suggest the emoji. I can give you a live demo here. So this web app is developed in AnvilWorks, which is a Python-based web app. If I go in and type "I am happy because you are watching," and click on analyze, we'll get the appropriate emoji suggestion here. This problem of detecting emotions from plain text has been mostly addressed as a binary classification of happy, sad, or happy, sad, and neutral. In this project, I tried to push it further to classify plain text into 6 dominant emotion categories of sadness, neutral, happy, anger, fear, and disgust. The data was obtained using Beautiful Soap Library to scrape data from Twitter, and these were messages on Twitter that had one emoji next to them. And standard Python libraries such as NumPy, Pandas, and also Keras for deep learning work was also utilized in this project. Here I'm going to walk you step by step through the pipeline. There is a crucial initial pre-processing step that was achieved by NLTK library to do spell correction, lowering case all the letters, and removing repeated words. So here I'm showing you an example of a sentence with mistakes, repeated words that goes through the pre-processing step, and the output would be a nice and clean sentence that's ready for analysis. The second step in the pipeline is to classifying emotion of a sentence as neutral or non-neutral. I solved it by using a combination of long short-term memory and a convolutional neural network because recent work have shown that this combination can provide superior result compared to traditional tools. The schematic of the tool is shown on the bottom. First, sentences are converted to vectors, then they go through the sequential part, then the convolutional part, and finally max pooling layer. If I apply this setting to classification of the 6 classes of emotions, the confusion matrix shows high F1 score for all classes except for the neutral. And this is because of the fact that the neutral class is more difficult than other classes to classify. It does not have specific keywords and it can take any shape, so it's harder to train the network to detect neutral compared to other classes. To overcome this challenge, I rephrased the problem as a binary classification of neutral and non-neutral, and I used all the data to train the same network, which dramatically improved F1 score. Now that the difficult class of neutral is out of the way, I could use a simpler random forest classifier to classify the rest of 5 emotions. And so this training was performed based on count vector features, and the F1 score for the 6 classes is above 70%. which is really good compared to available method. Overall, on the top, you can see the complete pipeline. A plain text goes through the pre-processing, then neutral or non-neutral, and finally rest of 5 other classes of emotions to result in the appropriate emoji. So my name is MazKhansari. I have a PhD in biomedical engineering and a master in electrical and computer engineering. Currently, I'm doing a postdoc at the University of Southern California. The focus of my work is on computer vision, data science, and machine learning. Thank you very much for watching. I hope you find it useful.